Virtualization is the abstraction of the essential properties of a collection from its implementation. A persistent collection can be viewed as the procedures that manage the flow of technology through the collection. From this viewpoint, collection properties are maintained while new versions of technology are added to the infrastructure. The role of a data management system is to manage interactions with continually evolving data storage systems, authentication protocols, network transport protocols, and databases. A collection requires continual attention to verify that the collection properties are being correctly maintained. Virtualization layers are used to manage interactions with technology. Data grids map from actions requested by clients to standard operations and then to the protocols required by the specific technology choice. The standard operations are held invariant. The knowledge needed to interact with each new technology is captured in the virtualization layer. The type of data management application determines the collection properties that should be managed. Every collection has a set of properties related to the operations that are performed upon the contained digital objects. Common properties include naming. Digital objects within a collection are named. A logical file name can be assigned independently of the physical file name used in a storage system. This requires that the collection manage the mapping from the logical file name to the physical file name. Arrangement. Collections provide a way to organize similar digital objects into groups or subcollections. By grouping logical file names, files from multiple storage locations can appear in the same logical collection. Identity. To control access, the identity of each user needs to be authenticated. An access control defines a relationship between the user identity and a file or collection name. Every access should be authenticated. Authorization. Every operation should be authorized by checking access control lists. Context. A collection uses descriptive, provenance, and administrative metadata to define the meaning, origin, and management of each file. Queries. In addition to browsing collections for similar data sets, queries can be issued on the metadata to find relevant files. Through schema indirection, storage of metadata name and metadata value, arbitrary metadata attributes can be added to objects. Data access. To ensure client actions are enabled across all storage systems, the actions have to be translated to the protocol required by each type of storage system or database. A data grid is the software middleware that implements the virtualization layers needed to manage both data and analyses. The data grid software is installed at each site where data will be stored or computation will be performed. The data grid maps from the actions requested by a client to the protocols required by the technology choice as shown here. Each client action is trapped at a policy enforcement point and mapped to standard operations supported by the data grid. Each operation is encapsulated in a microservice. The microservices invoke standard POSIX-IO operations. The POSIX-IO operations are then mapped to the protocol required by the choice of storage technology. These levels of indirection make it possible for arbitrary clients to access any storage system supported by the data grid. The client talks to the data grid, and in turn, the data grid talks to the storage system. The iRODS data grid implements policy-based data management by accessing a rule engine each time a policy enforcement point is reached. The rule engine references a local rule base to determine which policy to apply. The iRODS data grid is a peer-to-peer server environment as shown here. The component servers include a metadata catalog, which holds the descriptive and administrative metadata, a queue for managing deferred and periodic rules, a messaging system for out-of-band communication, and storage servers. Rule engines are located at each server. When a client accesses any of the servers, the access is authenticated. Information is retrieved from the metadata catalog to determine where the data files are located. The access permissions are checked. The requested action is performed at the appropriate storage server, and the results are sent back to the user. Data grids implement the ability for a user to access a file in a collection without knowing where the file is stored, without knowing the physical file name, without having an account at the remote system, and without knowing what protocol is required by the storage system. Take 7 minutes to answer exercise 7. Write a paragraph on the virtualization mechanisms you will need when accessing heterogeneous technology. What properties need to be managed independently of the choice of technology? Think about challenges with interacting with multiple types of storage systems, tape, file system, object store, or managing authentication across InCommon, Shibboleth, Onion, or Kerberos, or file naming on file systems in archives or in object stores. Please load your paragraph into the Lifetime Library in the sub-collection class INLS 624 by the end of today's class.